So today we are doing Circles and Arcs 10.6.1. The question of the day today is, what is one job you can never do and why? So I don't think I could do any of the jobs that are like a 24-hour shift type thing, because I definitely like my sleep. So I think like nurses or something that is like a 12-hour, 24-hour shift, I wouldn't be able to do that. Anyways, getting into the lesson, we are finding the area measures of central angles and arcs today. So the first definition here is, what is a central angle? I'm going to go back for a second up here and just make a note. If we have an angle like this, right where the two sides meet, this is the vertex. So this should be reviewed, but just in case, there's a note. So a central angle is kind of like it sounds. It's an angle with a vertex at the center of the circle that then comes out to the edge. So an angle with vertex at the center of a circle. So for the example over here, we're going to be using the same one for a couple of these. If I put this right here and label it C for center, and then draw something out, we'll label this one A, and this one B. Angle ABC would then be a central angle. So we could say angle ABC is a central angle. So then the arc measure is the measure of an arc. So an arc, first of all, is part of a circle. So here, like this chunk, this would be an arc. And then the measure of an arc is some sort of degrees or some angle. So like 50 degrees, 30 degrees. And if you want to find the measure of an arc, it's going to be the same as a central angle. So your measure of an arc is the same as your measure of the central angle. So this right here is your important thing to remember. So then over here, keeping the same color, AB is going to be your arc, and you mark an arc with like a little arc over the picture. And then if I label this angle, if we say this is 50 degrees, then you can say the measure of angle ABC equals the measure of your arc AB, which then is 50 degrees. All right. So the next one is a semicircle. A semicircle is exactly half a circle. So 180 degrees, half a circle. So it have the center still be here, and you're going to come all the way across and go like this. So this would be your semicircle. You have 180 degrees. This is your diameter. Next is a major arc. So this is some sort of arc or part of a circle that is greater than half or greater than a semicircle. So bigger than a semicircle. Or 180 degrees. And then how you would name this is you want to use 3 letters. So on this example over here, if let's say we have our center, we can make an A and B again. And then I'm going to put D over here. So if I say I want this arc, so the purple one, that's obviously a major arc. It's bigger than half the circle. So you could say ADB or like BDA, but you want to have 3 letters is a major arc. So then a minor arc, it just means it's less than 180 or less than a half a circle. So smaller than a semicircle. Or less than 180. Here you would name a minor arc using 2 letters. So if we want to name this AB right here, so again, it's smaller than 180, so it's going to be a minor arc. We can name this AB, or you could say like BA is a minor arc. All right, those are the only definitions we have, and so we'll go on to 2 examples. Here, this first problem, it wants us to figure out the measures of each of these, so what do they equal? So the first one, we're looking at BC, so it's this chunk right here. Again, the measure of the arc is the same as the measure of the angle, so if the angle is 32, the arc is also 32. And then if we want to find BD, you want to go from B to D, so we want this one, we can take the 32 plus the 58 to get our measure. So 32 plus 58, and you should get 90 degrees for that one. Next, we have some major arcs. So we have A, B, C here. You want to start at A, go to B, and then go to C. So we have this purple arc. If you look here, you can see this line coming straight across. That means it's a semicircle. So exactly half the circle at this point. So we have 180 degrees. And the last one we'll do in green, we're doing AB. So start at A and go to B. Like that. So we know this chunk is 32, and we know this whole chunk is 180. So you can subtract the 2 and do 180 minus 32 to get your missing angle, which would be 148 degrees. So here's one more example. You could pause the video and try this on your own and then check your answers. All right, so this example we have PR. So start at P, go to R, and you get this chunk. Our angle here is already given, so that one we won't have to do any calculating. We're just 77 degrees. The next one is R to S, so start at R, go to S. If you look here, this is a straight line across, so it makes a semicircle. So we can do 180 and subtract 77 to get the answer of 103 degrees. Now we're going to do these major arcs. Here you want to be careful that you go in order of them when you label. So you want to start at P, go to R, and then end at Q. So we're going this direction. So here we have 180 right there, and we want a little bit more. So I'm going to do 180 plus 28 to get a final answer of 208 degrees. And the last one on here is going to be PQR. So start at P, go to Q, end at R. So we're coming this way. So again, we have 180 right here, plus this chunk of RS. So you can do 180 plus 103 to get 283. Or you can do 360, so all the way around the circle, and subtract 77 to get 283. And then again, as I said before, you don't have to do this assignment. This is optional for extra. You need to do the Math Excel for 10.6 and the 10.6 check-in.